Hello, everybody. Let's look at a very interesting topic called tables, graphs, and charts. It is a very small topic under management accounting, but it is one of the most essential topics of management accounting. Uh, so tables, graph, and charts. Tables would be a very small concept, whereas graphs and charts would be something that we would look into uh in depth, in detail. Okay, so let's begin with what a table is. So a table, all right? Table is very simple. It is a simple way of presenting data using rows, using columns. So now let's create a table. That's called this column quarter and this column is sales. And we could do quarter 1, 2, 3, 4. And then we could have sales here. Let's say 10,000, 12,000, 15,000, 18,000. Let's convert this into a table. So this is a table where you have rows and where you have columns. Simple? Now, uh, it is a very simple way of presenting data using rows and columns. As you can see, it is a very good way to organize and to structure data, making it very easy to understand, very easy to read. Okay, think of this like a spreadsheet. Okay, now we can quickly here see which quarter indicates what amount of sales. Very simple. Okay, now let's get into graphs. Let's get into charts. Now, graphs and charts are what? They are a visual representation of data. Okay, they're used to summarize, they're used to present information in a way that is very easy to understand. There are different type of graphs. There are bar charts, there are line graphs, there are scatter diagrams, you have pie charts. Now let's take a closer look at each of these. Talking about bar charts. How would a bar chart look? So let's take an example. Okay. Let's talk about cars. Okay. It is, um, we could say category. All right. Where you have sales. Now you have a sedan, you have a hatchback, and you have, say, an SUV. And the sales could be, say, 50,000, could be 30,000, and say it could have 20,000. All right. Now, first and foremost, I convert this into a table. Okay. After I convert this into a table, what can I do? I can now show this on a graph known as a bar chart. All right. So small little graph. Um, let's put it on this side so that it's easy for you to understand. So you could see sedan, which has 50,000 sales, right? Then you can see your hatchback, which has 30,000 sales, and you can see your SUV, which has your 20,000 sales. Now, this particular line, horizontal, that is your x-axis, and your x-axis is indicating what? Your category. And you have your y-axis, which is not shown here, but it's a vertical line where all of these sale numbers lie. And so that is called your sales line. All right. Excuse me a second. Yeah. All right. Now, I am extremely sorry for this inconvenience. It was a small technical issue that happened. So we were looking at bar charts. So as you can see, this x-axis has your categories, the y-axis has your sale numbers, and this is known as a simple bar chart. How would you define a bar chart? A bar chart is a type of graph that uses bars. These are known as bars. All right. And each bar represents data. It represents a category, and the height of the bar, as in the height of the bar, will represent the values, right? And we have an example here. Now, you have different kind of bar charts, okay? You have a simple bar chart, you have a component bar chart, you have a percentage component bar chart, and now you have a compound bar chart. You have 4 type of bar charts. We'd look into each and every bar chart. Let's first talk about a simple bar chart. All right, a simple bar chart was something that we did. Now we could look into something called a component bar chart. Component bar chart. How would a component bar chart look? It is a similar type of a table with extra items, extra, you could say an extra hint of information. So we will still talk about cars, we would still talk about the sales, but this time we would involve regions in it. All right, you have regions, north, south, east, and you have west. And then we could talk about cars, which would be sedan, hatchback, and you could have your SUV in place, right? Let's put some numbers down. You could do this as 20,000, 15,000, 10,000. You could take 5,000 here. Then for hatchback, you could take a $15,000, $10,000 sales, $5,000 sales. Let's keep zero over here. SUV, you could take 10,000, you could take 5,000, you could put a zero here and here. Now, first and foremost, always convert this into a neat and clean table. You have a table. Now, since this is a component bar chart, this would be a little different from how a normal simple bar chart looks. Okay, I will put the table down here. Yeah. This is how a component bar chart looks. If you can see, the bars here are north, south, east, and west, and the values are on the x-axis. Sedan is denoted as the blue color, hatchback is the orange color, and this green color is your SUV. Since hatchback and SUV in east and west do not have any kind of sales, there is no green patch here, right? Apart from that, you can see this much of north, the car SUV indicates 10,000. 45,000 minus 35,000 gives you 10,000. Very simple way of reading a component bar chart. I'm sure we've all done these type of charts in our 11th and 12th standard. This was just a small brush up, all right? Now, this was about component bar charts. Basically, they show sales data of 3 categories of cars in 4 different regions. Not too difficult. Now, when you talk about a percentage component bar chart, a percentage component bar chart, it is very, it is the same thing, all right, but instead of the values, we have percentages, say 40%, you could have a 30% here, you could have 20%, you could have 10%, then here you could say you could have 30% again, you could have 25%, 15%, 5%. And then for SUV, you could have 30%, 45%, 65%, 85%, normal. Okay. So basically, these are component bar charts where it shows you sales. It shows data of 3 different categories of cars and again the 4 regions, but this is in fact in the form of percentage. Put this in a form of table, which it already is in, and then you could draw a graph, which is very much similar to a normal component bar chart. But the difference here is that this particular axis, which is the y-axis, will now denote percentages. These are in point forms. You just have to convert this into percentage instead of the numbers here, which is shown in the normal component bar chart. Is this getting clear? These are the normal percentages. Okay. Now, these are the two top types of component bar charts. Now we will talk about something called as your compound bar chart. This also has bars. Okay. This is a little different. Let's take the same values we took for component bar chart. Paste it down here. Put it in a table. Now, how would a component bar, a compound bar chart look? This is what a compound bar chart would look like. Have a look. Now, instead of showing bifurcations in one particular bar, they have shown one region with 3 different bars of colors. In one region, you have a sedan, you have hatchback, you have SUV of 20, you have 15, and then you have 10, right? Same way for a hatchback, they've shown you south, 15,000 of sedan, 10,000 of hatchback, and 5,000 of SUV. Since there's nothing in west, there is nothing. All right. So I think this graph is a little incorrect because it is a recommended graph by Excel, but I hope you get an idea as to what I'm saying. There will be bars. All right. Now west has no SUVs. Neither east has an SUV. So they're not showing any kind of SUV. All right. SUV is the green color. I think the color is an issue here, but that shouldn't be an issue. Okay. So this was about bar charts. Talking about line graphs, you have something called a simple line graph. Okay. Now, a line graph is a type of graph that uses lines to represent any kind of data. Each line will represent a category. The points on the line will represent the value. For example, if I take the same quarter example and sales, okay, you have quarter 1, 2, 3, and 4. And you could take sales as 10,000, 12,000, 15,000, and 18,000. Always convert it into tables first. Format this, convert it into a table. So you don't have Excel working and making of graphs for this paper, but you would have it in your future papers. Not the making of graph, but making of tables, and understanding how to read a graph is very important in papers before. So before you had your computer-based ACCA papers, it used to all be on a piece of paper. So this drawing was essential, but now it isn't. Lucky you, but you still need to know how to read a graph. And in order to know how to read a graph, you need to know how to make a graph. So a line graph would somewhat look like, give me a second. It would, since this is a simple line graph, you could go for a simple one. So this is what your line graph would look like. A very small line graph, as you can see. You can see in quarter one, your sales at 10,000. And then in quarter two, it goes up to 12. Then in quarter three, it goes up to 15 and then 18,000, right? At the same time, if say quarter five, if you add a quarter five here, which goes down, then this line would also go down. If say this would become 15,000 or this would go back to 10, it would completely come down. This is what a line graph is. Very simple way of understanding how your sales are going, how it's progressing up and down. If you see stock market analysis, the charts that are shown over there are in the form of a line graph, right? But more than a normal simple line graph, they're in terms of a multiple line graph. That is what is used there, a multiple line graph. What happens in case of a multiple line graph? We would take an example so that it's easier to understand. We would do quarter here, but we would do 1, 2, 3, and 4. But this time we would take the 3 categories of cars that you were using: sedan, your hatchback, and you have your SUVs. And you could do 50,000. We could put 60,000. We could put a 70,000. We could put a 80,000. Then you have a hatchback as your 30,000. You have 40,000. Just any random amounts that I'm putting in so that your graph looks good. You could have 20,000, 30,000, 40,000, 50,000. Okay. Again, convert this into a proper table. Format this into a table. Insert a recommended chart. So these are not appropriate. We could do a line graph. Okay. Now, here what is happening is that your lines are typically all in a increasing way. So it goes from 50 to 80, 30 to 60, 20 to 50. So this is something that is happening. But if I were to say change the values of this, okay? If I were to put this here, if I say make this 20,000, take this as 80. If I make this as 70,000 and I put this back to 20,000, if I keep this as 10,000 and I'll make this say 22,000, right? Now, if I want to look at how my graph would look like, it would be a little up and down, right? See the graph. Isn't it a simple and a beautiful way to show the trend of various variables, various categories of cars and their sales? You can see the blue one here talks about SUV. If you see, SUV initially was somewhere around 22,000 in quarter one. It goes to 30, goes till 40, and then drops to 10, right? You can see in terms of a sedan, you can see it was at 50, it goes to 60, it drops to 20, and again goes back to an 80. In case of an hatchback, you can see it was at 30, it goes up till say 70, it drops to a 50, and then it drops all the more down to 20. If there was a rise, it will go up. So this is what a multiple line graph could look like. Okay. Then you have something called a scatter diagram. So what is a scatter diagram? It is a type of graph which uses points, okay, to represent its data. So if I say, let's put output and the costs. If I am having an output of say 1000 units, my cost is 10,000. If I have an output of 2000, my cost goes to say 30,000. If I have an output of 500, my cost is still at say 12,000. Okay, I'm just putting in random amounts. And if it's at 4,000, we have it at 40,000. I want it to be random, and so I'm allocating random costs to random outputs. Okay, it would be different in how your question would be framed. Now, let's look at a scatter diagram. Yeah, can you see? This is how your scatter diagram would look like. A scatter diagram is something where you cannot pass a single line, right? It's haywire, it's everywhere. If your output, which is on your x-axis, is at 500, then your cost would be somewhere around 10,000, which is on your y-axis. If your output is say 2,000, it is somewhere around 30,000. Can you see? If your output is 4,000, then your cost is around 40,000. If your output is 10, then your cost is 10. If your output is 500, the cost is 12. So this is a scatter diagram, which is very random. It is widely used to show a relationship between two variables in a very quantitative manner. Okay. But also you could say as output here is increasing, the cost is also increasing. But sometimes the output is increasing and the cost is decreasing. You could even have a diagram where you say this would be 20,000. So this changed. This would be 3,000 and this would be 30,000. Can you see now your diagram? Your scatter diagram, now you can pass one line. What can you conclude from this? That as your output is increasing, your cost is increasing. It's very simple. All right. Now, talking about your last topic, which is known as your pie charts. What are pie charts? All right, pie chart is it's a circular graph which shows how much different, how many different type of items can you show in one particular category. So, for example, we could do categories of cars only again. Let's do category and let's do sales. If you produce a sedan car, it sells around 40%. But you have to make sure that your pie, your circle, is within 100%. So out of 100, your sedan sells 40. There are 40 sedan cars which are sold. There are 30 hatchback cars that are sold. And in terms of SUV, there are 30 SUV cars that are sold. Put this in a table, as always. Format it, put in a table. How would a pie chart look? Can you see? Since sedan has the maximum amount of sales, it has the larger amount of shaded period. Hatchback is a 30, right? And SUV is also 30. So these two are equal. They're shaded with different colors. So this is basically it. Whenever you have to calculate any particular amount, what do? This entire thing comes up to 360 because you always measure this in degree terms. So if I have to calculate, say, the angle of sedan, how would I do it? Sedan, since it is out of 100, so obviously this is 40, not 40%, 40, because it is out of 100. So I'm selling 40% of 100, so 40 cars of 40 sedan cars. And my total comes up to 100. So if I have to calculate the angle, all I can do is I could do a 40 divide by 100, all right? And now I have to find this out. in degree terms. So I would always multiply this by a 360. So our answer is 144 degrees. This is how you calculate angles. We will do some questions in one of my videos where this concept would be even clearer in terms of how to calculate the angle in degree terms. All right. So I hope this helps you understand each of the topic. If you have any questions, you can always comment below. Thank you so much for watching my video. Stay tuned and subscribe for further videos.